Well, I just want to welcome everyone to the Data Vault North American Users Group. This is our quarterly meetup. We're really excited to have everybody with us today. My name is Cindy Meyerson. I am the newly appointed president of this auspicious group of users. So one of the things we'll talk about, for those of you who are joining us for the first time, or are here to learn a little bit more about this thing called Data Vault, I'm going to do a real quick walkthrough, very brief overview of exactly what Data Vault is. And I'm going to start by making a statement that I hope sticks with you in your mind forever. Data Vault is not a model, all right? Data Vault is a fully engineered information and analytics methodology. It's designed to deliver value to the business. It's a complete end-to-end information delivery solution. It's made up of three components or pillars: the methodology as a foundational pillar, the architecture that's based on that methodological foundation, and the modeling patterns. So for every one of the components, meaning the methodology, the architecture, the modeling patterns, right? All of those touch and span across people, which deals with, how the work around information delivery gets done; process, which is how data travels and has business rules applied that are needed to turn that data into information; and technology, the infrastructure, the tools, the technical aspects that are used to produce information to our business consumers. So at the foundation of Data Vault are a set of standards and recommended practices that ensure your data is 100% auditable to its source, and that consistent, repeatable patterns are followed that provide a reliable, scalable, and affordable approach that can be followed by information delivery teams. So when adhered to, these standards ensure that your data engineering and data management teams are only needing sort of to apply the very minimal modifications required as new data arrives or as existing data systems change. It removes the need to repeatedly refactor or re-engineer your processes or your model, and it eliminates these issues of cascading change or cascading impact when changes are introduced. So if you'd like to learn more, we encourage you to visit the Data Vault Alliance website or to reach out to our DVNAUG board members. All right. So today, I'm just quick rundown of our agenda today. Pavitra is going to introduce our board. Mary's going to be introducing our sponsors. Doug Needham will be introducing our first speaker, Kent Graziano. Kent, also known as the Data Warrior, is going to be talking about virtualization approaches for Data Vault 2. And then we're going to be hearing from the inventor, creator, and I'm going to say absolute authority on all things Data Vault, Dan Lindstedt. So Dan's going to be sharing insights on late arriving data, and if time permits, some insights on temporality. So next, Mary is going to introduce our final set of sponsors before we move into a 5-minute break. After the break, we're going to return, and Kent's going to introduce Raina Thomas from Zataris. Raina's going to be introducing, I'm going to say, a somewhat new feature in Zataris known as Fluid Data Vault. She'll correct me on that if I'm wrong. And then we'll have about a 10-minute Q&A. We're going to draw the prizes and announce our winners for prizes, and then we're going to wrap it up with a little announcement on what our next event's going to be. So with no further ado, I'm going to turn it over to Pavitra.
Hey, I'm Pavitra. I am going to be introducing the DVNAUG board. We had our elections a few weeks back, and here's the list of all of our board members. We have Cindy Meyerson, who's our president from the great state of Virginia, and also who runs Data Rebels. Jim Freyer is our treasurer from Texas, and he is JD Data Solutions. Mary Mink, who was our president, is now our VP of Sponsorship Services, and she's here in Texas currently, but is moving to Florida soon. She's with Resultant. Sam Bendayan is our VP of Marketing and is currently in Florida, again with Resultant. This is me, Pavitra. I am the secretary this year, and again, Texas and Resultant. Noel Cruz is the VP of Membership Services in Minnesota, and he's with Optum. Janet McFarland, who's our VP of Event Planning, is in the great state of Canada. Just kidding. She's in Canada, and she's with Alberta Motor Association. And Doug Needham is our VP of Technology Services, who is in Kentucky and is with DataOps.live.
Thank you, Pavitra. All right, Mary, it's all you, girl.
Hi, thank you. Anyway, we're very excited about today's event, and we couldn't do this without our sponsors. They're the ones that help support financially for us, and we would like to hear first from Resultant. Gammon, are you here?
I am here. Hello,
All
everybody.
right.
My name is
Hello.
Gammon Rodriguez from Resultant. As Mary just mentioned, I'm on our business development team here. But just a quick overview of Resultant. We were one of the founding sponsors of DVNAUG about 2.5 years ago. So we focus on data analytics projects and are very familiar with Data Vault specifically. Right now, we have over 16 Data Vault practitioners, 5 of which are certified on CDVP2. And we've successfully completed over 12 Data Vault projects in the last few years. So as you just saw on the previous 2 slides, we have 3 current Resultant members that are on the board, and we also had 3 Resultant employees that were on the founding board. We have the largest number of Airscape Red and 3D consultants in North America, and we also have done work with Coalesce Data Vault implementations. At the end of the day, we implement business-centric data vaults and follow a methodical, agile approach. So as we're experienced technologists, we're ready to support teams on implementing Data Vault and mentor your team to ensure that your Data Vault projects succeed. And please feel free to reach out to me. I believe my information will be in an email or something along those lines. If you guys have more questions about Data Vaults or data analytics in general, and we're happy to support you. Good to be here, and thank you.
Thank you, Gammon. And our next sponsor actually is not with us today, but is Vault Speed. And they have got an awesome Data Vault, I'm going to say acceleration tool. I call them acceleration tools, not automation tools. So next up, we have John Price with Seven Rivers.
It's actually
Yes,
John
guys.
Steinbeck
Hello.
today.
Hey, Joel, I'm going to ask you to mute, would you please?
Oh, it's Joel. Okay.
My bad.
No, John Steinbeck is going to be presenting for Seven Rivers. I'm asking Joel to mute, please.
Oh, okay.
Thank you.
Sorry, John Steinbeck. It's one of the Johns.
Right? No relation to John Steinbeck. Well, GT2, Performance GT2, we merged with Seven Rivers to offer AI built on the powerful Data Vault 2.0 methodology. As well, we're partners with Snowflake, and PG2 is one of the authorized Data Vault training partners. We've got 50,000 hours of Data Vault 2 implementations, and we pretty much can use all of the tools that are out there for automation for most of you that are here. And that's us in a quick nutshell.
All right. All right. Thank you, John. And the next sponsor that we have is Data Vault Builders. And is Peter Bellis with us?
Yes, I'm here. Hi,
Yeah.
Cindy. Pleasure to be here. So what we are doing is, and I like your introduction, is we are creating a tool, not only automating a model, but we are automating everything around it. Means we are starting with infrastructure automation. We have tools for data profiling, for migrating models between environments, versioning code, automating documentation, automating data lineage, bringing it up to production, having scheduling built in, a lot of REST API. So this means that as soon as you want to start working in that direction, you can concentrate on the business-driven content. So you can really talk to your business users, and we do the stuff of generating code, versioning it, keeping its life cycle so that you save a lot of costs, save a lot of risk. And we're doing this kind of stuff for different clients in different industries, small clients like really small companies, bigger companies that did data warehousing before now going to the cloud. but as well now a lot of financial institutions, because we have bitemporal patterns for data vault built into the tool, which comes with the tool, which saves you a lot of cost if you have this kind of bitemporal challenges.
All right, thank you, Peter. I think we have,
So we have Doug introducing Kent.
okay.
Hello, everyone. I'd like to introduce Kent. Kent and I have known each other for quite a while. We've followed his journey as a data warrior. He has done a lot to influence and to move along Data Vault in general, and specifically some very cool technologies that he's worked with. So, without further ado, Kent.
All right. Thanks, Doug. And yeah, in case you don't remember, we met at the very first WWDVC. You can see my screen. All right. So, this is, a compilation actually of information from like the last decade of some of the things that I've done. Dan and I have been talking a lot recently about some of the things that he's thinking about in Data Vault, and with Raina here to talk about Fluid Data Vault, seemed appropriate to talk a little bit about the history of using virtualization techniques in the Data Vault 2.0 world. And so that's what I'm going to run through here for us this afternoon, evening or morning, depending on wherever the heck you are. Now, if I can just get my that to work. So we'll talk about why we want to virtualize, a little background, and then I'm going to look at the architecture and approaches that I've taken on two of my projects, virtualized ODS and a thing called Geppetto. And I'm going to talk a little bit about Dan's proposal for the advanced virtual data vault architecture, and then we'll get a chance to have Raina talk about the Zataris's Fluid Data Vault, which uses virtualization techniques itself. So the whole reason is like, why are we even talking about virtualization? And the primary thing is to make your projects more agile, right? That's what I was always going for when I was trying to do these things. Have shorter iterations, get things out faster, being able to test them faster. One of the things I discovered early on was that it eliminated one of the major bottlenecks in, well, not even just data vault projects, all data warehousing projects, which was ETL. The time that it take to write specs for people to actually do the coding and then to do all the proper testing. So even with all the great automation tools we have, you still have to do the testing and all of that. And so if we can eliminate some of the moving parts, we can be more agile. And this was one of the principles of agile software development, maximizing the amount of work not done. And I interpreted that as, well, if we can avoid coding some things, that's, helping us get there faster. And my experience with a lot of my data warehousing projects is, unfortunately, the ETL was a bottleneck, and a lot of times because we were working with offshore contractors and they're trying to do CMM level 4, level 5, which meant everything had to be written in a spec exactly the way we wanted it coded. And if we didn't write it right, the ETL code didn't come back right. And so then we would have multiple iterations just trying to get it right because we didn't know how to articulate what we really wanted to do. So in the end, what I ended up doing in many situations, and I'm going to talk about two of them, is we started using database views to do some of the work for us because we had people on the team who could write SQL, and that made it a lot easier to do. And the problem that we're running into is, as you all know, the data is like exploding everywhere, right? Over the next 10 years, we expect it to grow, so large that you're not going to really be able to move or restructure all the data. And this is some information that Dan provided me. I'd seen these numbers. These numbers have gone up in the last couple of years. You're looking at more than 180 zettabytes of data by 2025. And here it is. It's 2024 now. So again, that's not very far off. We got unstructured and semi-structured data, things like JSON. are now making up an estimated 80% of data collected by enterprises. And I was actually on a webinar 2 days ago where they said, well, the more recent numbers now are saying 90%. As people are really starting to look around, is that so much of the data is not structured in a traditional database. I prefer the term semi-structured because even unstructured has some structure to it. And then from 2010 to 2020, the amount of data created, captured, copied, and consumed increased from 1.2 trillion gigabytes to 59 trillion gigabytes. That's 5,000% growth. So we've got a lot more data coming at us. That means it's going to take a lot more time and compute resources to move that data around and restructure it like we would have traditionally done. So we started talking about virtual data vaults, and I think it was around 2012, right around the time Dan was rolling out Data Vault 2. Even before that, the very first Data Vault conference, we were having discussions about it, and we were still really Data Vault 1 at that point. Roland Voss wrote a number of articles back then with his proposal for creating a virtual raw vault. But it was all at a very small scale because back at that time, it doesn't seem like that long ago to me, but it's over a decade ago, the compute resources weren't necessarily there to do some of the heavy lifting that we wanted to do. But we were able to get some early success with virtual data marts. And that's kind of where my story gets in here. So I had this project where we ended up building a virtual ODS. The client had needed a new reporting environment. They got a new operational system and the reports were crap and they couldn't really do what they needed to do. So they discovered that they really needed to do something like a data warehouse, though they didn't know what that was. And of course, they wanted it to be agile. They wanted stuff delivered quickly. They didn't have a lot of money, but at the same time, they wanted it to be future-proofed. And of course, I hear things like agile and reporting and future-proof, and I'm thinking, okay, Data Vault. And so we decided we would use the Data Vault 2 method and methodology and framework. So as Cindy said, it's not just the model. And so we decided for this project, we would take a Data Vault approach and see what we could do for them. And so this was phase one. This was, our high level architecture. They had said handheld devices. They were scanners. This was a warehouse system. They were tracking things moving in and out of a warehouse. They had a couple of sources here for the data sources. And we determined we're going to load that stuff into a staging layer. And then I built a virtual operational data store. So I basically built views and normalize the data and standardize the data so that they could build business objects universes on top of them because they wanted to do operational BI was the main thing. That's what they were really looking for. So we started with a staging area because everything that I've built in the data warehousing world, and including, of course, data vaults, we always decided we wanted a persistent staging area. And the only way to do virtualization, something has to be persistent somewhere, right? Everything can't be virtual. There has to be a starting point. So we decided we would have a physical staging layer and then put put views on top of that in order to get the operational reports. And this became our foundation for actually getting the actual analytic requirements out of the customer, because they really, really, really did not know what they needed or what they were doing for that matter, right? And so we wanted to get there as quickly as we could. They had business objects, that's what they were going to use, and they had people who knew business objects. So we wanted to get the data to them as quick as possible. And so we had, like I said, the data warehouse stage layer based on the source system structures like we would normally do. And so they were being refreshed a couple of times a day, but we were doing change data capture in that layer. So it really was a type, we'll call it a type 2, a persistent stage area where the deltas were actually being captured, but the structures were still basically replications of the data from the sources. And then our virtual operational data store was an abstraction layer between the source and the reports. Just like we do with a information mart in the data vault architecture. That's our abstraction layer between the raw vault and the end users, putting it in a form that the tools could use and that the people would understand. So we started off with really views against the stage layer initially, thinking we're going to put a data vault in between later. We also did modeling. We used, data modeling tools. We made sure we modeled foreign key constraints so we know what the joins were, updated everything. The operational data store, we used business names and the proper joins there so that the people that were operating it would have an understanding rather than the arcane names that were in the source tables. Now, our plan was for a phase 2, which you can see here, that's everything that's in yellow on this diagram. So we were going to go from a data warehouse stage area to a data vault for the enterprise data warehouse, and then build virtual analytic data marts on top of the data vault and build some analytics universes. And then still keep the virtual ODS. We would just repoint the virtual ODS. Instead of looking directly at the data warehouse stage layer, it's going to look at the data vault. So we're going to have 2 things operating in parallel, virtual analytic data marts and a virtual ODS built on top of a data vault architecture to enable both operational reporting and analytic reporting. So, you all know the reasons for doing a data vault, and that's why it was in the proposal. So we had the consistent source, we had source system agnostic structures, et cetera, all of that sort of thing. And that then allowed us to put them in a position so that they could do analytics and do trend analysis and things like that. That wasn't going to be as easy to do on the third normal form operational data store. Now, the other thing that we had in the plan is we wanted to make sure that adding the data vault would be transparent to the business objects users, the business that we're going to do the reporting. So we had to make sure that the references in the business objects universes didn't have to be changed. And that was the whole reason for putting the operational data store in place in the first place, is that we knew we could then interpose a data vault for the long term into the architecture without disrupting the first phase of what we had delivered. So the analytic universes were, as I said, really what we consider virtual data marts that are on top of that. So we could, again, have another abstraction layer, but both the virtual ODS and the analytic data marts were going to point at the single data vault. So that was going to be our source of truth. And we figured, of course, as everything, if we needed to, we could convert to physical marts if the performance wasn't there, which in the end, we did not end up having to do. So just as an example, so you can see kind of what this looked like. This is our stage table. We adopted standardized naming conventions and suffixes, so _STG was for stage. We calculated a primary key, and this is where the data vault starts coming in. So Dan and I had already been discussing Data Vault 2 and using hash keys. I'd been doing it for a couple of years. So I said, well, I'm going to do this with the stage tables as well. And so we actually did a calculated primary key, and I have more explanation of what went into that, which was at the time was an MD5 hash. And we were doing this all in SQL Server. So we had the original source system primary keys indicated on the diagram. I was using Oracle Data Modeler for anybody that cares. So the U there indicates unique key constraints. So we were making sure that we added all the metadata after we reverse engineered in the source tables and then started building these stage tables so that we would have the information built into the model. And then we added metadata columns to support everything we're going to do. So you see here a hash key, which I'll explain. That was a little bit different. That's basically what we call business key now in Data Vault 2. A little different than what we were doing with the primary key. And a hash diff, so we could do the change data capture, your load date, and record source. So you should all be very familiar with these. So we had these in the stage tables. And that's how we were able to make these, delta-aware stage tables. And this became our persistence layer because we were going to virtualize everything else downstream. So we did load views in order to load everything in. So we went to an ELT type loading, doing type 2 SCD sorts of change data capture built into it. Built it all in Oracle SQL Developer, using their view builder, did all the testing, all sorts of things that we would normally do. I'm not going to get into a lot of details on that. When you get the look at the slides later, if you're at all interested, here's how we did the hash calculations. This was in SQL Server specifically. So having to use their hash bytes and some conversions in order to apply all the Data Vault standards for getting good hash keys. But we actually built templates. So I had template code so that we could easily replicate for every new source table. We could build these load views and have all of the calculations in there that we wanted. So as I said, the primary key was a little different. For the stage table, it was all the source fields and the load date because it was going to be delta directed, right? And so I didn't want to have a two-part primary key like we do in a satellite. So I threw the load date into the hash and called that the primary key for the stage table itself. Turned out that could also be used as a primary key for a type 2 slowly changing dimension further down the line. The hash key was what we basically call the business key now. And so we calculated that. Hash diff, you're all familiar with that. That was how we did our change data capture. We have an explanation for those that are completely new to the hash diff approach, why we do that in Data Vault, rather than doing the old way, which was simply comparing all of the columns to each other on an insert. We concatenate it all together, apply a standard hash algorithm, whether it's MD5 or SHA-256 or any of the number of other ones out there following the Data Vault 2.0 standards. We apply that to make it faster, so we only have one column to compare. And turned out those were always way faster. In traditional data warehousing, I often ran into the problem if you had a lot of columns to compare, then nobody ever wanted to write the compares for all of the columns. You got people saying, well, we only care if these 3 columns change. And so all the CDC was built on not all of the columns. And then when they decide later that they wanted to see, if a different column changed, you had to rewrite your change data capture. So we've eliminated that problem with the hash diff. We just put all the columns in that are coming from the source and use that comparison. So the virtual ODS itself, this is a look at the views that we built. We even had put foreign keys in the diagram so that you know what the relationships were. In this case, we had platform details and platform detail types. We changed all of the column names to be human readable, albeit with underscores in between. So load number, item number, reason code, increment number, load sequence, quantity, weight, transaction price, things like that. That was part of what we were doing so that people, the analysts that were looking at this, these were the names that they saw on the screens in their source system. And so these made sense to the business users rather than what was actually stored in the database itself. So like I said, we have the views, the tables and columns were all renamed to use business terms, but we still did do a little bit like a V prefix so that we knew that it was a view in the database. Put all the terms in, changed everything. And then we added the foreign keys because when they imported the data into business objects, this made it easier for the business objects developers to make sure that they were doing the right joins so that we didn't get any weird Cartesian products. Used analytic functions because the stage tables were type 2, right? And we're doing changes. In the case of this version of SQL Server, we used a rank function and put views on top of everything with a rank function embedded in the where clause so that we would always sort it in reverse order. And in this case, we're filtering just for the most recent row. And again, you'll have access to these, so you can take a look later at the actual code if you haven't seen this technique before. One thing to know is you can't use these analytic functions in a where clause, so we had to embed them in a virtual table in the from clause. instead. So we use the current, created a current flag, and we're able to do that in the outerwear. And this is true in Oracle, SQL Server, and Snowflake for sure. Those I know. I don't know about the other databases, but you could not at the time embed an analytic function actually in the where clause itself. So this is, again, a little example there where we've embedded a table. Inside of that, other people use other techniques. This is what we used at the time. So this is the actual code that we used. And this was in like 2014, 2015 when I did this. So the second case of virtualization was this thing that we ended up calling Geppetto, which was basically a hybrid virtual data vault approach. And so this was, oops, lost a page there. This was actually in 2012, so very beginning of Data Vault 2. It wasn't published yet, but Dan and I were having a lot of conversations when I got this particular gig at McKesson Specialty Health, that they needed a new data warehouse. They had an existing one. It was pure Kimball with a transient stage area. And they had things called facts and dimensions, but the more we got into it, the more they really weren't. And they did things like started deleting things in the stage area 2 months before they ended up getting audited, and we couldn't prove the data that was in the star schema was accurate because we'd lost all the source data because they blew it away because they were trying to save disk space. It also couldn't handle multiple source systems. That was a major problem because they were building a brand new source system, and they needed the data warehouse to not only have the historical data from their old source systems, but also from the new source system. So they decided they wanted to build a flexible, scalable, agile data warehouse. And so that, of course, sounds like Data Vault. I ended up getting interviewed for the position, and my buddy Keith Hoyle got hired internally to work on this. Our management was convinced by someone who didn't know what they were talking about that Data Vault was going to be too hard. So we were forbidden from using Data Vault after we were hired to actually build it using a Data Vault. Dan and I had loads of fun conversations about this particular aspect of the job. But nobody said we couldn't apply the Data Vault architecture because basically they didn't know that we were using Data Vault architecture and methods. So just like the project I just showed you before, we started with a type 2 persistent staging area so that we could start loading right away because they wanted to see results right away. And since they originally said, we're just going to do star schemas, no enterprise data warehouse, that's going to be too hard, too many layers, it's going to take too long. So we said, okay, well, let's start with this type 2 staging area. Very similar to what you saw on the prior screens. We included these things, we called them plumbing fields, and they were basically the standard metadata. You see a CDC key, CDC adder was, I think I have an explanation of this later in there. That's basically your hash key. You notice they're all varchar 32 because we were using MD5 hashes at the time. There wasn't a binary available. Where this was actually in the Oracle database. So we used the soon to be revealed Data Vault 2 techniques, thanks to Dan. We were able to do that, and we had record source and record source table. We had to break that down a little extra, and load date timestamp. And one of the things you'll see here is there's no expiration date, because at the time in Data Vault 1, people were still doing load date timestamps and expiry date timestamps, and we went to an insert only model, again on advice from Dan. Let's see if we can do this. Can we do this insert only? And that's where we learned how to use all these analytic functions. So again, the primary key, all fields. So just like you saw in the prior one, and in this case, we actually ended up doing virtual facts and dimensions, and using this hashed primary key became the key for the type 2 slowly changing dimensions. It actually worked out really, really well. The CDC's key was really our hash key. The CDC adder is really what we now call hash diff in Data Vault 2. We were just making stuff up as we did this, and it turned out a lot of them ended up being standards just with different names. And then we had this natural key thing that we ended up not using at all, but we added it in thinking we might need it. So we started off building marts just like you saw before, which were just views off of the stage tables. And again, it was business objects. Imagine, it seemed to be, it was a very popular thing there that people were using business objects. And this approach worked fine with one source system. And then we got into adding a second source system. We didn't have a data vault in here because we were told we couldn't do data vault, right? We're going just straight from the stage tables, straight to facts and dimension views, because they wanted to get everything done very fast. So once we started trying to add in additional sources, okay, so the stage area is growing and you've got all kinds of stage tables. And now we're having to modify the views. Every time we add a new source, you got to modify a view, right? And redo the mapping. And so the views became very, very complex. And eventually we got them to understand that, wow, maybe we need a persistent integration layer. We call it a persistent integration layer rather than a data warehouse, based on natural business keys. And it's like, well, that sounds like a really good idea, because you've got to have a consistent key even for a type 2 slowly changing dimension, right? How do you know what are you varying on? And you have to have that persistent key even over in the Kimball approach. But again, we're not allowed to say the words data vault. Never say data vault. And so Keith Hoyle actually came up with this diagram to show them, somewhat mathematically, in terms that they could understand, what was about to happen to them, where we had these various stage tables and sources. And as we added more, you were just getting a lot more lines crossing because, you had multiple sources for each dimension. You had multiple sources for each fact. And it was going to get very, very complicated and going to be a lot more coding involved. But then if you put a persistent integration layer in the middle, well, you map the sources to that integration layer once, and then the resulting integrated data can be mapped to any number of dimensions and facts, and again, just once, right? And you all know this, again, this is standard Data Vault 2 architecture. We do soft integration with hubs, right? So we don't have to write new code. We get new customer information from 3 different sources, and now everything on our reporting side that has customer referrals, we have to write code for all of that. So this allowed us to eliminate that. And this diagram, honestly, this is the thing that sold it. When we put that diagram up on the big screen for the VP, his eyes went boing, and he equated all those little lines to dollars. Every one of those lines was going to cost him more money. So he liked the bottom picture better because to him it meant it was going to cost him less money. But again, we couldn't say data vault. So what we came up with was this thing, we called it Geppetto. And that was an inside joke with Keith and I, because you know who Geppetto is. He's the master of Pinocchio. And so we decided, this was the puppet master. We're going to basically do data vault and say, don't look at the man behind the screen pulling the strings. Just look at what's happening in front of you. So we came up with this architecture. All the keys were MD5 based. We did the 3 layers, the data vault architecture with stage, which you already seen, the persistent integration layer, raw vault, and a presentation layer. But to build it then, what we said is, we were going to build these tables called domains. And domains are business keys, and that's it. They were hubs. Basically, we started backwards. We said, okay, we know we need hubs and links. What are we going to call them? And Dan and I came up with, I think, the name relators. And then we had to do this weird key mapping thing. And that's Dan and I worked on that in Helsinki, Finland, at a Oracle user conference there in 2014. First time Data Vault got introduced to Finland. And Dan and I had a chat by the lake in a national park there about this particular concept. And what are we going to call this? We'll call it a key mapping table. And this was going to allow us to basically map the hubs and the links to the stage tables, and the stage tables were going to act as our satellites because they were already type 2. It was not ideal, but we weren't allowed to replicate the data. So we had to find a way to get the right logical, conceptual business ontology structure in place so that we could do the integration without building out a full data vault. And like I said, we just changed the names to protect the guilty, as it were. Domains and relators, they are hubs and links. In the presentation, I said, well, they're like hubs and they're basically links, but no, they're hubs and links. Just so we're clear with everybody here, when you see it, you go, yeah, that's a hub. But it managed to make sure that we didn't get fired because we did data vault. So here's our D_loc is basically hub location, but D for domain. So we had, again, the MD5 hash keys there, did the calculated hash keys. We had all the business key columns there. In this case, it was a multi-part business key. This is one of the examples I like to use because so many people get confused on this with Data Vault. They think they're looking for one column in the source system that's going to be their business key. And like, that's not the case. The real world business keys often are multi-part. And this was, in fact, a very large number of columns that were the actual business key for locations for McKesson. And we were tracking oncology clinics. And it took us a while to figure it out. And we had to do the conceptual modeling with the business, just like you would building any normal data vault, to get the definitions from them without talking about technology. It's like, how do you identify a new location in the McKesson Oncology Network? And eventually we got down to, it was the name plus the street address, city, state, and zip. Because sometimes they had 2 clinics in one building, but it was thought of and treated as a completely separate location, even though physically it was not separate. And so we had to add name in as well. And then at the bottom, what you see is our key mapping table, which is the join, is how we joined off to the stage tables. So honestly, this is harder than Data Vault. But since they told us we couldn't do Data Vault, we had to go the hard way. And so the red in the middle there is basically a link table. And one of the things Dan and I had been talking about is for performance reasons, we might consider denormalizing the business key from the participating hubs into a link so you don't have to do the join out for certain types of analytics. And so even though, I don't know what you call this, Dan, it's not a, is it a best practice? I don't think it's a best practice.
It's a recommended practice.
That's it.
And
yeah.
This particular object, we decided it would be in the business vault logically. Physically, it's, as you see, it's embedded in the model. So it's just another table. But if you're going to do this, it's a business vault object because you're running business rules to consolidate the keys. Kent, back to you.
Yep. Thank you, Dan. But this was the first time. So this was like 20, let's see. So we talked about it. It was, this was 2014. So it's probably one of the first times that this was done. And we tested that out. And we were, again, using Oracle. And we knew we were going to put virtualization on top of this. So we wanted to eliminate some of the joins and eliminate some of the performance contention we would get in the Oracle database. So that was one of the reasons that's there. And you see underneath all of these, just like you would see satellites in a normal data vault, you have these key mapping tables, which are nothing more than the joins over to the stage tables. Made quite the spider web when we were done. And again, just as another example here, this is the stage table on the right with the CDC key embedded over into the key mapping table on the left. Looking at this backwards. Yes. Left side of the screen is the stage table. Right side is the key mapping table. So why are we talking about this is because basically we found a way to apply all the Data Vault 2 standards, even as they were being developed, the concepts and the methodology, but we did not build physical hubs, links, and satellites. In reality, we built physical hubs and links, but we did not build satellites. But we did follow all the logical concepts in order to make this work. And the way it ended up looking, this was our plan. We were going to do separate schemas for each of these things. So we were going to have an integration schema, a stage schema, and then you see just-in-time transformation there. That was how we were going to build out the reporting. And all the star schemas and data marts, whatever form they were going to be, were all going to be virtual. So the persistent integration layer, though, just included these D underscore, KM underscore, and R underscore tables. And all of the various stage tables mapped to the key mapping tables. We abstracted and extracted the business key information from the stage tables, and that was the only thing we replicated into the domains and the relators. Because one of our mandates was to not replicate data unnecessarily. You see how this might tie into the very first part of this presentation, talk about how data is getting so big, we can't replicate all the data. Well, this was before that was too much of a problem, but we were told not to replicate the data because there were cost constraints in the amount of disk space that they could afford for this system. So we had to find a way to reduce that. And we were able to do that by not replicating all the stage data into satellites, but we still did have to do hubs and links, and all we really replicated were the business keys, the business key columns. And then on the presentation side, we had views, and this is a whole nother presentation. They were hybrid type 1 and type 2 dimensions expressed in views, and that's why you see SCD2 provider key and SCD1 provider key there. And those were all mapped over in the views. No calculations were actually done on the fly in this case. These were columns that were either in the stage tables or inside of the domains and relators. And then we built a whole bunch of views on top of this to make it all work. Now, from a loading perspective, we couldn't see any reason why we wouldn't load all these things in parallel, even back in 2014. That was crazy. We had the parallel query option on Oracle, and so we figured, hey, we can do this. It's not going to stress the system too much. So we were hoping to load the domains and relators in parallel with the stage tables because it's the same data. The only thing we're taking out of the source system for the domains and relators was going to be the business key columns, and then everything else was also going to load into stage. And then we would go from there with our integration. But again, management in its infinite wisdom decided they knew more than we did and told us we were not allowed to load them in parallel because some DBA somewhere was afraid we might crash the system. So they never even let us test it because the DBA said no. So we ended up doing a more traditional approach of loading the stage areas first, and then the integration layers, and then everything from there forward was virtualized. Now, the challenges of this is we had to, just like Data Vault, you've got to have real business keys, right? So you had to have a solid enterprise logical model, which we spent 3 months doing JAD sessions with doctors and physicians and clinicians to get the terminology right. And then we converted that model into a Data Vault model to determine how we would build the domains and relators. And that's also where we got the terminology for everything that was going to show up in the views, right, as to what the terms were going to be. Mapping the disparate sources to an integration layer, and this is true of Data Vault, is hard. If people do not have an understanding of the semantic meaning of the data in the source systems, they're not going to get it right. We constantly had people who were supposedly helping us with the ETL coming back and saying they couldn't find the business keys. We needed to change the domain. We had to change the table, or we needed a different one because this particular source didn't have that business key. And the challenge is that the terms we used, the business terms that were used in the logical model, didn't map one for one to the words used as column names in the source systems. It's the difference between cust name and customer name threw people off. PT for patient instead of writing it out, threw them off. And so this was one of the things that we learned early on, is we had to make sure that people understood the definitions. We had to have definitions of all this and teach them how to do data profiling so that they could see that the values were the same, even though the column names might not be what they expected. The dimensional modelers in particular did have a real hard time with that. And so hence we used views for the presentation layer to interpret this all for them so that they didn't have to go figure it out. Now, the advantage was, of course, we were able to start staging immediately and not losing any history, right? Because we were using the type 2 staging area. We had definitely a very clear line of sight from our presentation layer back to the sources, and we were able to be very agile in our approach. If they gave us the wrong business rules, it was a change to code in a view in the end. So just like you would do with the business vault. We had the persistent history was already there, and so we were able to adapt very, very quickly. Now on to the new stuff, advanced virtual data vault. So all of this is a lead into this discussion about where do we go from here. And this is something Dan proposed at WWDVC 22, so 2 years ago, is a way of adding more virtualization so we don't have to move the data around. So as I said, it's a set of pit bridge hybrid structures, to basically denormalization that we're going to do that. And it's still a data vault and still following the data vault rules. So just like what I was showing you what I did over the last decade, advanced virtual data vault is the same thing. It's, even though it's not going to have physical hubs and links, it has logically modeled hubs and links, just like I was doing in the prior two examples that I just showed you. Is we're basically going to denormalize it, but the modeling approach and the way we think about it and the methodology is the same. We're just trying to avoid that situation of it's just going to take too long to move the data, right? Proceed with caution, as Dan said. I'm glad Dan's on the call here because he's going to go nod his head yes. You know, don't try this at home, folks. This is one of those, we're thinking about it. It's experimental. Don't try to do it on your own. We're presenting it here for concept to say where we're going and where we're potentially going in the future with Data Vault. So here's what it looks like architecturally. At the top, you say your normal Data Vault approach, right? Stage tables, raw vaults, business vault, information mart, all based on conceptual and logical models. And what you have from, I'll say a physical perspective on your advanced virtual data vault is you still have the same thing, except that you're going with pit hybrid tables, pit bridge. I keep saying that wrong. Pit bridge hybrid tables. We got to come up with a different name for that, Dan. It's too hard to say. Which are denormalized from the logical models.
I call them peanut butter tables.
Yeah, peanut butter tables. Okay, yes. We can spread it all out. Yeah. So, Dan and I have been having this conversation probably for the last decade about the value of the data vault approach from a conceptual and logical perspective. It gives us a way to model things and explain things to the business and understand the business. It doesn't necessarily have to end up physicalized in the database other than for performance reasons. So where did the thing go? Okay. And so here's what you've got. You're still going to have here delta-driven stages. I've just shown you two examples of what a delta-driven stage table looks like. And that's something that you're probably going to need in order to make this work, to do this advanced virtual data vault approach work. And there's another one coming here. Yes. And so what that ends up looking like is just like I had views for all my reporting layer. In this case, you're using views for your actual data vault layer. So you get the raw data vault, the business vault, and the information marts. Those are all virtualized or views sitting on top of the pit bridge hybrid tables in combination with the delta-driven stage tables. So very much like I just showed you with Geppetto, only it's taking it to the next level where we still had the physical hubs and links and this weird key mapping table. Basically, Dan's replaced that with the pit bridge hybrids handle what we were doing with domains, relators, and a key mapping table. He's rolled it all into one structure, right? And joining back then to the type 2 persistent staging area and putting views on top of it to then make a raw vault structure and then your business vaults and your information marts. Now, I can tell you this will work on certain things like Snowflake. I'm sure it's going to work on Snowflake because we had customers using views for their business vault and information marts 6 years ago because of the JSON feature in Snowflake. They were loading everything into a satellite that basically had one attribute, and that attribute was a Snowflake variant, which was a JSON structure. And then then they built business vaults on top of that. The raw vault was a hub and a satellite with one column. And so they got very close to this and had no performance problems at all. So they had both the business vault and the information marts were virtualized. And so this next thing that Dan's proposing here is the raw vault itself is also virtualized. So I know this can be done. Again, it has not been tested at massive scale, but I'm very confident that this can be done in the right circumstances. Some of the questions that this comes up with is when should you apply it? And that's, as we said earlier, if moving and restructuring the data is too costly because it's too big. Is it across the board? The answer is no. You would only use it if you have these particular circumstances. So you may have a very standard data vault architecture with physical hubs, links, and satellites, maybe even physical business vault structures, pits and bridges, all of that. And then this is, for certain parts of your infrastructure where you have this massive amount that's like orders of magnitude bigger than everything you've done so far, where, yeah, you're maybe attaching to, like Snowflake can now attach to iceberg tables, right? Something very large like that. And then you're going to end up using views, but it still is going to be a data vault. It's still all going to be working in there together. Does it replace the existing data vault? No, it's an add-on. At this point, we'd never recommend somebody just do their entire data vault this way, right? A fair amount of risk involved in that right now. Data vault's complex enough. This is something that if you get your back up against the wall, this is a potential option to solve when you have these very, very large systems. So consideration, not ready for prime time. So this is the red alert, danger, Will Robinson, danger, Will Robinson. Don't try this at home alone. It is, as Dan says, it's really a thought experiment inside a Data Vault Alliance. Needs a lot more testing because, as you know, Dan has harped on this for, over 2 decades now. It's like we're not going to put anything into the Data Vault standards that has not been tested at scale. The difference is, what does that scale mean in 2001 versus now 2024? Has a completely different meaning now. We are beyond orders of magnitude bigger and need to be able to handle orders of magnitude bigger than we did when Data Vault first started. So that is a very important consideration. And then you get the best practices and all that. So if you're interested in this particular approach, put something up on the Data Vault Alliance forums, ask Dan, get a call with Dan. Don't call me, call him, just saying. I'm not volunteering for this one. And so the next is, this brings us up to the Zataris Fluid Data Vault, and I'm not going to talk about that. I'm going to let Raina do that when we get to her part of the presentation. The thing that we want to be cautious of in all of this is make sure we, Dan says, don't throw off the emperor's groove. So let's not forget to leverage Data Vault 2 and its entire system. And that's what I did with my other 2 projects, my real projects. Just made sure I applied the thought and the concepts of Data Vault 2. Being lazy, not properly identifying and defining business keys, still a major problem. Love all the automation vendors out there and all of our sponsors, but it gets very easy for people to reverse engineer one source system and use some of these tools and generate a data vault. And basically they built a source system data vault. And they shortcut a lot of the work of the tools. All give you the opportunity to define a real business key, but a lot of people take shortcuts and just go for whatever the primary key is in the source. So that's a laziness thing. I like the way this is put. Yeah, this came from Dan. Not starting a business from a business use case. Don't build it if they don't need it. Not collaborating with all of your source providers, and not collaborating with DVA, and at least using the DVA forums to ask questions. And some of you have done that really, really well. So conclusion for my presentation here is that if you plan properly and you use a good architecture, you can be agile, you can save time, you can save money, you can save disk space, as long as you're using the logical approach to Data Vault for your modeling. That's where you've got to start. Stick with the Data Vault, the proven Data Vault methods and standards, the recommended loading practices. There's recommended loading practices for adding loading stage tables. Follow those. Use delta detection in all cases. Use views wherever you can, so you can be agile and you make fast changes on the fly. And if you need to, you build things physically to meet if the performance objectives are truly business objectives. Fast enough is fast enough. Don't waste a lot of time building tables and indexes to get millisecond difference response time. Make sure there's a real pressing business need to go faster before you start physicalizing things. Oops. Excuse me. So I've set myself an alarm so I didn't talk too long. You don't have to have physical hubs, links, and satellites to be a real data vault. That's my number one message there. So you can still do a real data vault following the methodologies, following the system that Dan has laid out without actually building physical hubs, links, and satellites. And if I had said that 10 years ago, people would have been running me out of town on a rail thinking I was out of my mind. But, having now done it multiple times, it's true. It works. The standards, the principles all work if you apply them. You just have to be a little creative at times. Only recent book I have to advertise, I would throw this in there, is my Introduction to Agile Data Engineering using Data Vault 2.0. Still out there on Amazon. You can get it in paperback or Kindle format. And you all know how to find me, mostly Twitter. I do not post a lot on my blog that much anymore since I'm mostly retired, so I don't do a lot of blog writing anymore, other than for a couple of my clients. But you all know where to find me. I will be at WWDVC this year. So if you want to see me in person, head up to Stowe, Vermont, and I will see you there. And
Thank you,
that,
Kent.
as they say, is that. Stop sharing. Boom.
Thank you, Kent. I'm going to bring up Dan's slide. You've got some questions. You can look at the chatter in the chat, and maybe you want to add something to that.
Holy cow! Yeah, there's a lot of chat going on there while I was talking.
A lot of chat. All right, so we are moving up to Dan's words of wisdom. So as many of you know, Dan is the inventor and creator of Data Vault. He is the authority when it comes to standards related to Data Vault and recommended practices. So Dan's going to share his words of wisdom with us. Dan, you have some slides you want me to bring up? You speak to this
I
real
got
quick?
some slides if I could share my screen. Sure.
Sure. Do you want to speak to any of these things we have up here on the Data Vault portion? Okay, real quick.
Hey, look, everybody, we've got the conference this year, and I guarantee you it's going to be awesome. You should try to make it. I know it's short notice, but we got Kent is going to be there. We got CJ Date. If you've ever read any Cod and Date work, you've read CJ Date's work, one of the founding fathers of data management himself, temporality and so on. So phenomenal individual, one of the nicest guys you'll ever meet in person, one of the humblest guys, brilliant beyond belief. And then, of course, we got Scott Ambler running a workshop. We'd love to have you there. And I think Cindy can send out a discount coupon for you if you haven't registered yet. The other thing that you see there is a starter membership and the pro membership. It's free to have a starter membership. We will soon be introducing another layer, an intro membership. I'm not sure what we're going to call it, but some of the starter stuff is going to go away. So if you want access to the starter membership and all that it has, get signed up today if you don't have an account. That'll give you a year's worth of access to everything that's there. Anyhow, so that's something to think about. The pro membership, we have monthly meetings with the pro members. They're monthly webinars where you can ask questions of myself and Cindy directly, and we answer them right for you. And then we have quarterly catch-ups where we pick a topic or a theme of interest and we talk about it there as well. So there's a lot going on in the pro membership that you can't ignore. It's like getting me for $997 and you get more than 12 hours of my time every year. Plus you get Cindy's time as well. So really kind of cool stuff. All right, so we should move on. And let's share my screen here. Now, I prepared these in rapid fashion. They're all text. They're unlike my typical slideshow. So I apologize. The other thing I'll say is that we have CDVP 2.1 coming. We're about to make announcements on all of that. And our current ATP partners or authorized training partners include Scale-Free and Ignition, which you may know as Certus in Australia, and Data Rebels. Today, we do not have any agreements with Seven Rivers, and we hope that that will come around in the near future. Okay, so just to let you know, if you're looking for training today, definitely go to one of our existing ATPs. You can always come to us as well. So beyond that, I don't have much time, so let's get into it. Late arriving data. This is a very brief and high-level overview talking about late arriving data, and I promised a few of you to mention some of the ideas that Kent brought up. So this is my agenda for now. So we're going to talk a little bit about understanding late arriving data, why load date must persist, and then we'll finish it up with all about the applied date concept. And what does this have to do with Kent's presentation? Unfortunately or fortunately, quite a lot. Kent and I worked together on that solution for quite some time to help get it virtualized. And if you look at the dates at which he built that system in 2014, 2015, which he mentioned multiple times, we were up against a lot of challenges, technologically speaking, that we overcame. Today, the challenges, there's quite a few less challenges. There's bigger, faster hardware, there's cloud, there's all kinds of things that have gone on to make things possible. But back then we had no choice. We had to run delta processing on the way in to handle the ultimate size of the data sets that we were dealing with in order to make the views work. We had to do things like partition and rolling partitions on the staging tables, because back then, if you had an ever-growing staging table, you would have problems with performance in your views. So don't think that everything was just as easy as slapping a stage table together, loading it with a bunch of data, and then throwing views on top of it. Even today, it's not that easy, and we don't recommend that you do this on your own or that you just simply try it that way, because virtualization will crash and burn if you go that direction. Due to data volumes, due to data complexity, especially for bringing in JSON objects into your staging area, that can add a layer of complexity on top of it, even if you've got a platform that adds compression. So just be careful. Definitely contact us if you want to know more about Advanced Virtual Data Vault. We will have courseware coming up along with CDVP 2.1. We're going to be talking about courseware that will be available, as well as workshops that we can help you build AVDV and spot solutions for you going forward. So definitely something to think about. But beside that, what does that have to do with today's talk? It has to do with this aspect of delta-driven processing. Delta-driven processing, you may have heard in class that all roads lead to change data capture. The concept of delta-driven. Eventually, data will get too big to move or restructure, or I should say or restructure. And when that happens, you start to question whether or not you can even run delta processing based on the size of the data that is arriving in a chunk, or based on the frequency of arriving data. If it's too fast, you may not have the luxury of running deltas on the way in to either your data lake or your file system or even your staging tables. So we have to talk about late arriving data because that's what CDC produces. That's what change data capture actually gives you. That's what audit logs give you, are all of these changes. And it may or may not be late arriving. The problem is, in a data warehousing world, we simply don't know. We don't know if the data is going to be late arriving or not. So late arriving data is data arrives that in an analytical storage space that was generated or updated on a previous timeline. So the data itself, I apologize for the sloppy definition. This is mine. I did not have time to groom it and clean it. It will be cleaned up. We're preparing an actual course on temporality and late arriving data. And so that's coming as well. Where that timeline does not line up with the date and the time of the data was loaded to the warehouse. So you may be thinking, what else do I need in order to identify late arriving data? Well, there are two specific things that are required to identify late arriving data. The first is at least one additional timeline. And this has to come from the source. If you don't have any other timeline except the load date, you can't determine when this data was actually originated. And we call this concept applied date, right? The other thing that you need to have or must have is a consistent key. And we like to say consistent business key if you can get it. And yes, surrogates might work for some period of time until they change the source system or until they export and reload the data and it gets a new surrogate. Then all your history's broken, right? But that ties into the data vault methodology that we teach. But you have to be able to, in order to run a delta, you have to be able to tie the existing data to what you got previously. And that's the only way you can do it. This is not a data vault problem, folks. This is a data warehousing problem. And a lot of people blame the data vault for this. And they say, it's data vault, it's the fault of the data vault, too complex, too difficult, can't do this. And it's not a data vault problem. It's a temporality problem that has existed in data warehousing since the beginning of data warehousing when Bill Inman put out the first definitions. So this is something I think you should read. We will put this link up in the chat for everybody before the end of the show, as soon as I'm done. And it is a well-written, small reading piece that talks about windowing and late arriving data. And it really does a good job of defining how that works. So if you have late arriving data and you're talking about concepts and you're talking about applied date, why should load date persist? Well, because load date governs the delta process. Load date is the systematic approach. Load date isn't going anywhere anytime soon, folks. You've got to have it because you're going to get data from different timelines, from different servers, from different places in the cloud, from different time zones, and you need a way to coalesce it. You need a way to understand from a system perspective, when was it loaded to the database? And that doesn't go away either. And that's a data warehousing component. So you're still going to have a load date and a consistent timeline, even with late arriving data. So it provides a solid timeline for governing the data itself, deciphering what went wrong, when it went wrong, and how the data was affected by the issue. It has other benefits as well. So this is where we start to talk a little bit about the question. There was a question that came up in terms of volume. Okay. Hopefully my mic volume's a little better. Sorry about that. I was a little quieter. Cindy, you can let me know if that's better. Otherwise, we'll do that. Okay, we're up more, or are we good? We're good. Okay. So delta processing. Delta processing in the data vault methodology has been around for a long time, and that's actually a data warehousing premise. And what we started with in the 90s and the early 2000s was this whole idea that most data warehouses operated on full table dumps or full source system dumps. And that's the way most data warehouses were built. That isn't the case anymore. As I've said for years, all roads lead to change data capture becoming a requirement in your data warehousing solution. And so what does that mean? Well, it means that having to do the delta processing on load, the requirement there, it softens a bit. It means that you might not have to do it in certain circumstances. Now, I'm not talking across the board here. This is not a blanket statement for you to run out and rip out all your delta processing going into your stage or into your loading process or into your data lake. Definitely don't do that. This is a point solution for extreme volumes or extreme speed, right? In certain instances, CDC feeds you data so fast, you can't do delta processing. In other instances, you get so much data dumped on you, hundreds of millions of records inside of 15 minutes, for example, because it's a huge file dump, and you can't do delta processing. In other instances, dealing with, for instance, image or documents or audio or video files, you get massive data sets. Then you have to start asking the question, what exactly does a delta mean? And how do I do it? These are data lake problems, right? And data lake is a concept, by the way. It doesn't mean file store. It doesn't mean a stage area. And by the way, data lake, the definition of data lake inside Data Vault warehousing basically means that it may include your staging area. So just bury that away, right? So delta processing is not required on load in some instances. This allows you to turn delta processing into a soft business rule, move it downstream, right? But you still got to do it somewhere because business expects analytics to run this way. They need to see the changes over time because that's how the analytic works. That's how the functions of progression and all those other things mathematically work. So we try to tie this to something called applied date as a concept. It opens up the use of more alternative timelines. And by the way, I got one more bone to pick here. And that is about this idea that Data Vault is bitemporal. It's not. Data Vault is multi-temporal, not bitemporal. Bitemporal means only two timelines, two and only two. And Data Vault can handle as many timelines or temporalities as you want to throw at it. So it is multi-temporal. So let's correct the technology and the language here. So if you're not running Delta on load, do you still need a load date? No. But we do recommend it for the reason I just stated. If I'm not running a Delta on load, do I still want a load date? Absolutely. There's a lot of benefits to it. So why and where should Deltas be run if they're not on load? Now, the first thing I want to say is this. If you are no longer doing Delta processing, the first place you want to go to fight for it is upstream on the source system. You want those source systems delivering audit logs and CDC right from the source. That's where it belongs. That's where it should be. And that will correct an awful lot of problems, detecting deletes, detecting missing data, detecting late arriving, and all kinds of things. CDC should be as far upstream as possible. And that will also move your company towards real-time enablement, service solutions, microarchitectures, and so on. So on the way to pits and bridges or peanut butter tables, downstream aggregates, you can do it. And a delta for one business unit might be a different delta for a different business unit based on the same data set sitting in your staging table. Now we use this as a persistent stage. This goes on what Kent just presented, building off of that idea that you have a persistent staging area embellished with Data Vault system fields and Data Vault processes and so on. But you need to understand the applied date concept. So we'll try to finish this up. I guess I've got 4 minutes left, or am I already over time?
You're a bit over, but you were a bit
Can I
late
take
starting.
4 more minutes?
Go for it. Just finish
All
it.
right. So we'll finish it. So applied date, conceptual representation of one or more timelines. Again, don't just see this word and think it's a single column. It's not. It allows different deltas to be produced downstream by different sets of business rules. Here are some examples. And again, applied date is a concept, not a physical field called applied date 1, applied date 2. Don't go do that. Use the business names, but you can group them in the logical model with the notion that these are applied dates, right? Where do they apply to the business logic or to the BI outcome? That's why it's a concept. And you can use windowing functions and order by and all kinds of wonderful things when moving data downstream to produce different delta sets. This allows late arriving data to arrive and be stored in the Data Vault in satellites or in persistent staging tables or in non-history satellites, those kinds of things. It allows that late arriving data to arrive, and then you do something with it. This is not a data vault problem. This is not a data vault solution. This comes from the world of streaming analytics. This is an idea that has been around a long, long time before me. So if you really want to read and you really want to dig into it deep and figure out how it works, go into streaming analytics. We'll also have courses that tie it directly to Data Vault for you that help you overcome all that. So never ever change or override the load date. We've been saying this for years. If you're doing this today, take some time when you do some mitigation and fixing to go adjust it so that you're not overriding the load date. So 2 more slides, we'll finish this up. This may be the last one here. When should you run or not run deltas on load? When you receive an audit trail that you simply want to warehouse, that becomes a transactional link, folks. An audit trail becomes a non-historized link or a transactional, a transactional link, okay? So when you see read-only transactions, when you need to backdate data downstream in the BI collections and reports, too many people waste time, waste development cycles and design cycles trying to re-engineer the load date to handle this. The problem is load date is one column. Applied dates can be more than one column. So it doesn't solve the problem. It kicks the can around, and then pretty soon you've got a different problem because it's not late arriving on this timeline anymore. It's late arriving on a different timeline, and you still can't deal with it. So you end up re-engineering your load date processing. So don't do that. Add applied date columns as needed, feed them from your source system, and start working with change data capture. So I've addressed a whole lot. That's the end of it. Hopefully, that's good for everybody.
Thank you, Dan. You can put your questions to Dan in the chat. I think you'll be around for just a few more minutes, perhaps.
Yes, I will. I'll try to answer some of these things.
Great, great. All right. You're going to jump right back. And Mary, you're up again. You there?
I'm here.
Okay.
Hey, all right. This was awesome. Thanks, Kent. Thanks, Dan. I love the chat. Oh my gosh. I think we have over 100 chats in there. This is awesome. This is what we like. We want participation. We want everybody to share their experiences. It's awesome. So now we're going to hear from 4 more of our sponsors. And the first up is Infovia. That would be Mike Kolosik.
Hello. Hey, Mary. Thank you. Hopefully you guys can hear me okay. I'm standing in an airport with lots of background noise, so my apologies. But so as Mary mentioned, my name is Mike Kolosik. I am the Chief Operating Officer for Infovia, and we are a data strategy and execution organization. So we help our clients not only execute on their strategies, but even help them put them together so that they can be successful and really looking at their projects from a holistic standpoint. So rather than just bringing in a data warehouse, we're looking at their data governance, their access control, their BI, and really focusing on how are they going to achieve some quick wins and really bring some real return on that investment to the table. So we currently work with several different industries. One example that we're currently working on is we're working with the entire state of Connecticut to bring a data vault into their 17 universities and colleges throughout the state. So exciting project. I'd love to help you out as well if you need help. And our contact information is going to be at the end of this webinar. Mary, back to you.
All right. Thanks, Mike. And next up from Data Rebels, the one and only Cindy Meyerson.
Well, thank you for being here today. Data Rebels is my primary company. I guess my other hat is COO for Data Vault Alliance. I don't know. I think actually that's the primary anymore. Anyway, so Data Rebels is an authorized training partner of Data Vault Alliance. We provide certified Data Vault 2.0 training, and we'll be providing 2.1 training when it's released. So our goal is to simply provide our clients with a way to move their teams forward We provide coaching and kickstarts, workshops, and things like that. So our goal is always to sort of, teach men to fish. We believe that most companies ought to be investing in their own employees with regard to building out their solutions. And so we try to encourage companies to invest in training for their own people. We come alongside and we coach those teams to help them with implementations after training is completed. Our Kickstart program, very simply, is a 10 business day program. The first 3 days are spent training everyone for the certification exam. On day 4, we begin an implementation, a very well-scoped sprint release, which we provide an outcome, a very specific outcome at the end of the remaining 7 days of the Kickstart. So if you're interested in something like that, as a proof of concept or something, please contact me. I'd love to talk to you about that. And then also we just augment consulting if you need that. Again, our main goal is to help the team drive forward. So we sort of take the strategy that Data Vault takes, which is, get in, get the data, and get out. We want to help you get moving, and then we want to allow you to continue to move on your own without us being in there constantly. So that's sort of the way we handle consulting. That's our consulting model. So anyway, please reach out to me if you'd like, and you can visit my website at datarebels.com. Happy to have a chat, and you can find training sessions and training classes coming up on the DVA website under the classes, and also on my Eventbrite site. So thank you.
Thanks, Cindy. Next up, we have Paul Kenier from Eon Collective.
Hi, everybody. This is Paul Kenier. I'm the Director of Data Vault Solutions at Eon Collective. I'm excited to be here today. It was an interesting start to this call, talking about how times have changed. I think that was our first TikTok troll we've ever had, right? But good that that was booted and this will not end up on TikTok. As a Director of Data Vault Solutions at Eon Collective, I help our customers implement their solutions. We don't just do Data Vault, but I love doing Data Vault. I manage a team of CDVP2s over here. I'm a CDVP2. We recommend that you get certified through Data Vault Alliance and the other certified practitioners and professors out in the industry. We do migrations. So if you have a lift and shift to a different technology, that's one of our main specialties. And we have strategists and lots of different. It was one really good thing that came out of ChatGPT. Give me a second here. Seamless migrations govern your systems with precision. And we're in the tri-state area. We're a global company. We are going to be at WWDVC this year. Very excited about that. You can probably catch me getting some Qigong training from Kent, which I'm excited for the most. And we look forward to seeing you there. Thank you, guys.
Okay. Thank you, Paul. And next up, we have Setha Kang from Warescape.
Great. Hi, everyone. I'm Setha Kang, and I'm an account executive here at Warescape. We're super happy to be sponsoring DVNAUG. Data automation is no longer a choice. As you know, Data Vault methodology emphasizes automation. And Warescape, we've been leaders in automation for over 22 years and partnered with Dan Lindstedt for over a decade. We can help build out your Data Vault end-to-end, from your ingestion to design and modeling, development, deployment, scheduling to documentation. And we can also add your star schemas and data marts on top of that. Warescape integrates with nearly any sources and over 17 different targets. So your Snowflake, your Azure, Databricks, or your on-prem SQL Server, Oracle, and Teradata. I like to think we're like good insurance. We provide full coverage. So by using templates and by having both technical and design knowledge built into the product means that the hundreds of objects and tens of thousands of lines of codes can be generated in a matter of hours. And because of automation, it works the first time. And because we're metadata driven, Wordscape can generate complete documentation. That includes your dependencies, your data lineage, with track back, track forward diagrams, change impact analysis for your developers and your analysts. So not only do we generate up to 95% of the coding for you, on top of that, with our modeling tool, we have the ability to automate the automation in mass. So to give you an idea of our speed, one large insurance said to me, Sita, Wordscape did more in your 2.5-day POC than we did in half a year. So, so data automation is no longer a choice, and Wordscape, we're the most comprehensive, most flexible data warehouse and data vault automation on this planet. So reach out to us and let's build your next data vault together. Thanks so much, guys.
Thank you, Sita.
Sure.
All right, let's pick up Raina. Oops, sorry, Kent. You want to introduce Raina for us?
Yeah, I gotta unmute here. Back on being mute. Yeah, we go to the next slide with Raina's bio on it. Yeah, so Raina is the VP of Product and Architecture at Zetaris. I've been advising and working with them for a couple of years now since I retired from Snowflake. She actually came to the Data Vault conference last year and showed an early version of what you're going to see today, Fluid Data Vault. She's highly energetic, motivated person. She's been in the Data Vault realm for a while. She actually is a certified Data Vault solution architect. She worked at Certus prior to her role now at Zetaris. She's lives over in Sydney, Australia, and so it's now like reasonable mid-morning for her now that we took so long. She's been very kind to spend her time to come and show this. I was very excited seeing it last year, and have been really working on getting her to do a presentation on Fluid Data Vault since May of last year. So finally, we got to do it. So glad to have her here. Take it away, Raina.
All right, Raina, I'm going to give you control of the screen. Should be able to share.
Thank you, Ken. That was amazing. So I don't need to introduce myself anymore. Last year, we had presented the Fluid Data Vault at the WWDVC, where we met with Cindy, Dan, and we had a lovely time presenting this concept. And we also collected a lot of feedback during this conference. Based on that feedback and based on my learning experiences of how we built the Data Vault across different projects in Australia. So I've worked with healthcare and I've worked with retail, particularly with Mercedes-Benz on implementing Data Vault structures here in Australia. I've put in a few structures in place within Zetaris. So Zetaris is a platform which is my product actually. So I'm the VP of Product and Architecture on Zetaris. And because I'm such a big Data Vault fan, the first thing I thought was, wow, this virtualized platform was something that would have made a lot of difference when we were implementing Data Vault across different projects. So based on my experience, I have put in Zetaris and the concept of the Fluid Data Vault. Sorry, I'm just trying to get this thing out of my way. Right. So introducing us, who are we? The team at Zetaris has been in this data management industry for around more than 20 years. And we started as a company in 2013, and it's headquartered in Melbourne, or was headquartered in Melbourne. Our head office is now moved to the US. So we've got offices across Melbourne, Vancouver, San Fran, Palo Alto. So we're more spreading out globally. Our whole idea is you can connect multiple data sources instead of trying to bring all of the data into one centralized location. So the whole idea is leave the data where it lives and query it at source. And to make this idea successful, the technology that we've used is Apache Spark. So the platform runs on an Apache Spark engine so that we can get kind of near real-time speed on the platform for all sorts of big data processing. Now, a base level architecture of how Zetaris works is you might have different kinds of source systems that are sitting on the platform. So you can see OLTP systems, you can have unstructured weblogs, or you can have streaming data coming in or REST APIs, or you can also have data lakes and databases. What Zetaris does is creates an intermediary layer of stitching together these data sources and then publishing it to whoever wants to consume it. Now, this entire layer remains virtual, so it doesn't need a rip and replace of any of your existing data sources. Now, how does this help us in building a fluid data vault? When I was implementing the data vault across a few projects in Australia, some of the challenges that I experienced was, one, as Dan mentioned, people have this notion that data vault is too time consuming or too complex because it goes through a lot of stages. And it's not just notional. I've experienced it at certain places when you try to create a physical load landing or a physical staging layer. It depends a lot upon the ability of your ETL tool on how fast processing is. So sometimes if your database is not optimized or if your ETL tool is not optimized, you end up spending half a day just loading data into your landing layer and then another probably 2 hours getting it to your staging layer. This is for huge data volumes. So the whole concept was, how about we keep the entire staging part of it virtual, and we either build a physical raw vault or we can have it a virtual raw vault. And the business vault will again be kind of a virtual view like Kent showed earlier. So how do we go about doing this? Last year, when I presented at the WWDVC, we had started with building up a virtual staging layer and then creating a raw vault on Snowflake. But technology has advanced a lot. So now we are using a lot of the newer technologies in place. So things like OpenAI, things like the Iceberg format for the target. So I'll do a demo today to show you what's happening where. But the whole concept basically is, let's try to avoid this area where we do the load landing and the staging in a physical layer. If we can do that in a virtual layer, it does improve the speed of and the repeatability of how much we can connect to our raw vault. So that's the whole idea. This is the entire flow. Are you able to see a black thing? No, right?
Well, I don't think we're seeing what you think we're seeing.
Yeah, we're just seeing your
Zoom
slide,
label,
Raina.
actually.
We just see your slide.
Okay, that's great, because I can see the Zoom label and that's what's bothering me, but that's fine. So this is the data flow diagram of how things work. So you might have different things like a database, you might have cloud services, what APIs coming in. And Zetaris has a inbuilt metastore where we collect all of this metadata information of whatever is incoming. We're only collecting the metadata information, not getting the data into Zetaris. So at runtime, we'll use this metadata information to create queries, to do the query pushdown, to optimize the query plan and everything. So that's the whole idea behind this metastore. So what happens in real time is all your live data would be coming in, and then we would be building a delta detection rule, which is going to be virtual. And this is built on something called as the Zetaris pipeline. So the Zetaris pipeline is actually an Apache Spark data frame pipeline. So you connect data frame after data frame on Apache Spark, but it's a visual pipeline. So you're abstracted from all of the complexity under the hoods. So we do all of this on the pipelines, and this part is all completely virtual. And once you do these pipelines, the Zetaris has an inbuilt metadata surveillance system. So you're actually continuously tracking, is your source system changing? Is your column being dropped? Is your column being added? And based on that, we create a logic for continuously maintaining your vault. So the second challenge that I noticed with our implementation of Data Vault across Australia was it's when as consultants we come in and we build raw vaults and we build informarts and we build business vaults. The moment we finish our work and we leave, people find it difficult to maintain it because columns are getting added frequently, columns are getting removed frequently. How do you manage new data sources? So how can we provide a pattern for all of those? That was what went through the thinking of generating this fluid data vault concept. And we've used these two features of Zetaris. One is a virtual concept where you can do things virtually on this platform. And the second is a metadata surveillance concept where you're continuously doing a surveillance on your source system and detecting if there is any change. If there is a change, then you're recommending a change to the vault as well, which goes through a version control mechanism where people can approve this change or not approve this change. As Dan mentioned, data management cannot be completely automated end to end without proper reviews in place. So we've put in those mechanical reviews in between where people can do a check of what is being proposed. So after you do this, we create a physical raw vault. And today I'll be creating a physical raw vault on AWS in Apache Iceberg. So there's a choice that we've made in terms of where do we output data. Can we create a raw vault on Snowflake, on databases? Yes, we can. Can we do it on the lakehouse, on the cloud? We can. But with Iceberg, the reason we chose it was because it has got great connectivity with other databases. So for example, Snowflake can refer to Iceberg as an external table. Iceberg itself has got some great features like time travel, and it's very easy to track information in it. And the compression mechanism also is quite comparable. So that's the reason why we chose Apache Iceberg as underlying lakehouse system for Zetaris. So today I'm going to show you how we create a automated or a Zetaris fluid vault on Iceberg. Now, what are the advantages of a fluid data vault? So as I said, we've got a built-in metadata surveillance, which will keep the data vault refreshed even if there are changes to the source system. Staging layer is completely virtual, so it keeps a light footprint on the database. And we are using AI for certain things like business key detection, PII detection. And this AI usage has come in after we presented at the Data Vault conference last year. So this has just come in this year when we've been experimenting with OpenAI and with certain NVIDIA models. And we discovered that another challenge of Data Vault was how do I identify a business key? So I've been in situations where people got dumps of files and they want to identify a business key and the column name doesn't make any sense. So how do I identify a business key? For that, we've had to go into the data, do some data profiling, read the data, understand it. How about if we use AI for a recommendation mechanism to identify the business keys? And that's what we've done with a combination of our own AI platform, Gen Z, and the Fluid Data Vault. So I'll be demonstrating that today. And we've been using virtual data pipelining. So the virtual data pipelining is a concept that is preparing the vault pretty quickly, and it's using a pattern, a repeatable pattern. Using that repeatable pattern, you can connect any kind of a source. You can connect a database source, you can connect a file source, and it'll do all of these things for you. It'll generate a business key recommendation. It'll generate the PII tag recommendations. It'll auto-generate the links for you. And all of this is happening through our virtual data pipelining capability. Now, what is the exact process that's happening in Fluid Data Vault? The first thing we do is when we register sources on Zetaris, we are reading the metadata and we infer the metadata into the platform. Second thing, we tag the business keys, or in last year when I presented at the Fluid Data Vault, we were tagging the business keys physically. So you needed a business SME to help you with tagging your business keys. Today, I'm going to show you that we'll be providing a recommendation for tags. You'll need a business SME to review those business keys, links, and the PII data. And then we execute the virtual data pipelines to auto-generate DDLs. Once the DDLs are generated, they go into GitHub where they get reviewed and approved. So once it's approved, you auto-generate the raw vault on the lakehouse. and you keep a schedule of metadata surveillance on Zetaris to keep a track of any columns that are changing and to modify your hash keys accordingly. So as the hash diffs depend a lot on your incoming columns, you'll need to maintain this metadata surveillance on your incoming columns to ensure that you're not missing out on any new information that's coming in. So this is broadly 6 steps in which we are doing the Fluid Data Vault. Now, I would just like to go over to the demo now. I don't want anybody to fall asleep. All right, let me just, where's my, can you see my screen?
Yes, yes.
Cool. So this is the Zetaris data platform that I was talking about. And with this data platform, what I'm going to do over here is I've got different options here. I can connect file systems, I can connect lake houses, I can connect databases, and I can connect Kafka streaming sources if you have got IoT data. So today's example will be mostly based on a Snowflake database that I have. So I've got a Snowflake database which has got a few tables sitting in it. So I've got something called patients, and I've got something called medications, prescriptions, and that sort of a thing. Now, the moment I register this Snowflake table, it goes into the Zetaris data catalog. The Zetaris data catalog is an auto-generated data catalog that reads the metadata coming from this Snowflake table. So if I look at this Snowflake table, I can see I've got a patients table here, which has got these sort of a column. And as you can see, there are no tags, no descriptions. And similar to that, I've got medications, no tags, no descriptions. I pre-generated a few of them to save time. So I've got prescriptions, which have got these kind of tags. And I've got visits. And I've also got something like a metadata change history. So if I look at my Snowflake table, you can see these are the things that have been happening. So some of the tables were dropped, some of the columns were removed. All of that history is being tracked here. And I've set this to an update cycle of a weekly. You can set it to an hourly cycle to maintain a more refreshed kind of a metadata surveillance. So now I've got these 5 tables and I've built a virtual data mart out of them. So let me just show you my virtual data mart. That's my patient data mart. And I've got these 4 tables sitting in here. The next thing what I do is I'll go to my AI platform, which is called Gen Z. And in today's example, I'll be using OpenAI. We've got 2 options. We can either use OpenAI or we can use private AI on GPU. So I'll be using the OpenAI feature in today's options. And I'll go to structured data and I'll say import dictionary. So when I say import dictionary, I'll go and try to create a dictionary for my patients table. And when I do that, it will generate a recommendation of business keys and PII information on this table. And this is all happening based on the content of the data. So even if you do not have proper column names, or even if you do not understand your source, OpenAI is actually reading your data and then giving you these recommendations. So if I go to the data catalog again, and I'll come back to Snowflake here, and I'll come to patients. So now you can see there are a few tags here. I've got a business key for my patient ID, and I've got these PII tagged over here, and I've got a dictionary for it. I need another data dictionary for my medications. So I'll just generate another data dictionary for my medications. And while that is generating, I want to show you something. So after this got tagged as PII, we've got a mechanism within the system which will auto encrypt this data. So if I come here and I look at my patient's data, you can see that it has created an encrypt policy for all non-admins on this database. And what that encrypt policy does is it is actually encrypting all the columns that were tagged as PII. So your first name, last name, gender, address, phone, email, whatever was recommended as PII gets encrypted over here. Now, all of this is not completely automated. So if you think some of these recommendations are wrong, because at the end of the day, it's AI. So if you think some of these recommendations are wrong, you can just remove the tags or you can just add the tags, whichever way you feel like. So now we'll go to medication and you can see it has generated a business key. And I don't think there's anything sensitive within medication, so there are no PII tags. Now with business keys, you will notice that, say for example, if I take this example, you have business keys that span across columns. So for prescriptions, it has identified 3 columns as business keys and not just a single primary key column that has been kept as the primary key for prescription ID. The whole logic is, how do you uniquely identify a particular prescription? And for that, you need a combination of these 3 columns. So based on these 3 columns, it will create a hash key in the data vault. So that's the ultimate concept. And then if you look at it, there's one more tag here which says, this visit links to prescription. And the link is happening via visit ID. So all of this has been auto-generated using the Gen Z application. So if I go to create relations and I select my data mart, this will auto-generate all the relations across different tables that are sitting in my data mart. And when it says auto-generate relations, what it does is it will just give this prompt to you that this is the way these things link to each other. It's not necessary for you to have a foreign key reference to identify this link, because as I said earlier, we are reading the data to identify these links. This comes in pretty handy when you're dealing with file sources, because you cannot tag foreign keys, etc. in file sources, in JSON files, in APIs. So that's where this comes in pretty handy. Now, after the relation is generated, I'm now going to create a lakehouse. Now I call it a lakehouse because I'm creating it on my AWS environment. So this is my AWS environment. In here, I've created a S3 bucket called Fluid Vault. So if I just pick out my here, I've created a bucket called Fluid Vault, which is pretty empty right now. Next thing what I'm going to do is I'll just click on the Generate Lakehouse button. So as you can see, the Fluid Vault is empty here. And the same Fluid Vault is being read in Zetaris. So I want to see the data in a proper tabular format. I don't want to read it via AWS, so I'll read it from here. So the Fluid Vault is empty here. It just has something called param_store. So now I'll just click on choose your source data mart. That's my patient data mart. And choose your target. Where do you want to create this? So I want to create it in my Fluid Vault bucket. And what is happening over here is it's running a series of Zetaris data pipelines. So in Zetaris, I've created this series of 8 pipelines, which are pretty generic and which just follows a particular pattern. So in here, what's happening is I'll just load this pipeline and show you. We just automated the SQL behind the pattern. So here is all of the complex SQL processing that's happening, which is putting it within certain naming conventions. It's identifying the hash diffs and the hash keys, and it's then creating staging tables or staging views. So it's virtual. So it's creating staging views in this container. So here you have all of your auto-generated staging views that have come through. Now, what happens when this finishes? It's still generating the staging views. I'll just refresh this and we can see it is generating the hubs and the sats. I think it's working its way through the links. Effectively, what it has done here, if I look at the structure of this, it has created the hubs and the sats and the links. So the hubs have a hash key, a hash diff, the load date, your record source, your primary key, whatever was a key, and a BKCC. Now, BKCC is something that that's something that I've added with my experience. When you do data vault across multiple data sources, and you have reached an advanced stage, that's when you realize with the addition of every new source, you are introducing a risk of a key clash. And in one of my experiences, I had to go back and redo because there was no BKCC at the beginning. So that's why in the whole structure, we have already pre-included a BKCC, which is a business key collision mechanism. So this BKCC will uniquely identify your combination of a business key. So say, for example, a customer exists across 2 regions with the same ID. You can identify the difference between these 2 customers by looking at the BKCC. Now, in this case, my BKCC is just what is the source from which the data is coming. So as I mentioned, it's created the hubs and it has also created the links with the hash keys and the hash diffs. And it has created the sats with all of the information for the hubs. Now, this is generating the structure. What is the next step? It's important for us to also try to automate the load. So what we've done is just click on populate lakehouse, choose your source, choose your target, and populate lakehouse. What it's doing at this phase is running the insert pipelines. So we've got a set of data pipelines. This is all the data pipelines are virtual. So whatever you do here are happening virtually. So we've got a set of insert pipelines here. And it's actually executing all of these pipelines one after the other. So whatever staging views have been generated, it'll pick up the delta and then load the data in the target. This might just take a couple of minutes. At the end of the day, this is how your S3 bucket and your iceberg data looks like. You can read it on a Snowflake, you can connect it elsewhere, or we are reading it on Zetaris here. So if I try to see the data came in, as you can see, I've got my medication hub in here, and I can see my medication IDs, my hash keys, and my hash diffs generated over here. And the BKCC here is Snowflake, where I'm identifying the source of the data as my business key. So in this way, what we can do is, it's not necessary for you to keep the BKCC as a source. In my previous example where I said I had to redo the whole thing to create a BKCC, we had data coming in from APAC, from EMEA, and from AMER, which had the same sort of IDs. So we had to differentiate it by region. So the BKCC was a region. So that's why we've just introduced a BKCC column. This can always be modified. Sorry. So that's our way of generating a lake house in an iceberg sort of an environment. And the simple thing, what we've done is we read from a database and we put it into a lake house. Now this can be in different sorts of combinations. The data mart that I showed you here can contain either Snowflake databases or can contain file sources, APIs, the Kafka streams, all disparate kind of data sources. So this is just an example with databases. Now I'll just stop it here and go back to my slideware for a moment. Conceptually, what's happening behind the scenes for our AI-powered lakehouse is this. So we've got data stewards who are trying to create a data mart with raw data. So data stewards know what is the data that should be consisting of your raw layer. So it's not a raw vault. It's what is your raw layer? What's your input? So they create a data mart with a virtual data mart with all raw data. Then the user clicks on import dictionary. In that case, the keys and the PII columns are identified and tagged. And when the user clicks on create relations, the AI identifies the links between sources, and that's also getting tagged in the Zetaris data catalog. Now you have an optional step here, whereas an admin, you can remove the tags, you can edit the tags, and you can also map tags. So say, for example, there's a cust table and there's a ccust table. So you can create a mapping sort of a tab which says ccust maps to cust. So you can do all of that in the Zetaris data catalog optionally. Then we have the button to create the lakehouse. So when you click on the create lakehouse button, it'll automatically create a virtual data capture layer, and then it'll apply this tag-based masking policy. So in case you're executing with a non-admin ID, your data gets populated into the lakehouse with encrypted data. So you won't get to see the actual data in the lakehouse. That's the whole concept behind tagging it and tagging PIIs and auto-generating that policy. So then this creates an auto creates a raw vault, or what we call it as a silver lakehouse. And this is also checking in DDL changes into GitHub. Now, there's another problem with some of my implementations is people wanted to know what's the version history of what's changing and when. So that's where it's quite important to show that you are able to track the version history of your DDLs as well, not just the data. So Dan keeps mentioning that data needs to have auditability and traceability, but not just that. From a technical perspective, people do want to know, are you able to track back to what the earlier DDL was? Because you're actually also maintaining the data vault at different points of time when your columns are changing, when your hash diffs are changing. So what we've done is we've created a mechanism here to kind of, once you generate your lakehouse, it will chuck in all your DDLs into the GitHub. So in my case, actually, I just chucked it in yesterday to practice. So yeah, so here is the latest run 4 minutes ago. So you've got all your current DDL statements sitting here, which goes through a review process. So you will have a pull request generated. Somebody will have to review it. And once it's reviewed and it goes into your GitHub, that's when the next step picks it up and creates your hub. So it's not an ungoverned process completely. So say you've got problems with what got created here in the DDL, you can put a stop here, correct your tags, and then rerun. So that's the whole idea behind keeping a version within the GitHub of the DDLs. Isn't just the DDLs, not the data. I need to flip back to the slide. So here what we've done is after we finish auto-generating the raw vault, we put it into the GitHub, and then the GitHub, whenever there's a change in the metadata surveillance thing, it keeps polling for changes. So the moment there's a change, it'll auto-create the raw vault with alter statements, and then it'll check it into the GitHub, and there will be a review process where somebody is reviewing it, and then it goes back again into loop. So that's the whole concept behind the Fluid Data Vault and its implementation in the Zetaris Lakehouse concept. Now that's it from me today. Thank you for your time, and thank you for listening to me. Last year's Data Vault conference gave us a lot of insights, and in fact, what Dan was mentioning today about late arriving data, that was a question that somebody asked me last year, how do we handle that? And thanks for all the information that we've got today. I had no answer to that one last year, but I guess we've got some answers now. It's great being part of this community, and I look forward to more interactions. Thank you so much.
Raina, thank you very much. That's impressive. I'm just going to say, like we did this in like 50 minutes, right? You ran through profile, basically built out the metadata, built out the whole pipeline. It's impressive. It's impressive.
Thank you.
Thank you. Thank you. Do we have any questions real quick? We're actually going to go into Q&A I think we got just a few minutes for that. And I don't want to cut anybody off from being able to ask Raina questions. So can we take 5 minutes for questions? If you guys have anything, post them in the chat for us, please. Or questions from Kent or Dan. Or Raina, your contact information is out there on your slide, so they can get in touch with you too. And all right, very cool.
Sure, and I'm there on LinkedIn.
Okay. Yes, I have you on LinkedIn.
I have a question. This is Mary.
Sure,
Hi. It was amazing, your presentation. My head was spinning the whole time. It's awesome.
Thank you.
So what you just ran through, it built the raw vault is what I saw, and it automatically looks for changes and detects changes that are coming across. Is that right?
That's correct.
So if the source adds a column, it will automatically detect it and add it in your
Yes, so
front.
if a source adds a column, it'll automatically detect it and add it to your satellite and add it to your hash diffs as well. So you got to add it everywhere, right?
Right. Wow, that's awesome. What about the business vault area where you have, your pit bridges and all your business logic? That
Yes.
I know you had limited time, so you showed us, this virtualization and of the raw vault, but what about that? The business vault and even to your info marts, like your star schemas.
Yes, so that's a part we are working on this year. So it's basically the business vault is not so easy to kind of automate or to put in a particular pattern because every business vault has different needs. There have been projects where I've worked on where there have been no business vaults. We've gone straight from raw vault to Infomart. So we're working on what can be a pattern that we can use for business vaults. So far, we just trying to kind of find a way if we can have natural language based user rules come in. So you got people who enter things in English and that turns into a business rule. It's a bit complex, but it's an ambitious idea. So that's on our roadmap this year. But unfortunately, no, we do not have an automation for business vault. We have it up to the raw vault so far.
Got it. Thank you.
Thank you.
We have one question from Kathy Wang. She's asking, is performance considered both loading and querying?
Sorry, is performance considered both loading and querying? Yes. So the performance part of it is taken care of by our Spark engine. So that's why I said virtualization is just not virtualization on database views. We're using Apache Spark for loading and querying to your source system. So yes, performance has been considered. However, if you ask me, have we done any load testing or performance testing on really big data? We haven't so far.
Thank you, Raina. I don't see any other questions. So if you're okay, let me make sure I got one more thing. Let's see. Which technologies are used for implementation apart from Apache Spark? Anything?
Yeah, so it's Apache Spark and we've used OpenAI and Python scripting.
Great. Thank you. All right. Well, I'm going to switch back real quick. We're going to, let's see. Am I sharing? No. Okay. Where am I? Hold on. Sorry, folks. Okay. Let's go to Q&A here. All right. So that's Q&A. We're going to move along. All right. So sponsor draws. Noel, I believe this is you, correct?
Indeed it is. And our prizes today are provided by all of our sponsors, 8 of them. We have $50 Amazon gift cards as well as a $50 Audible gift card. Now, this is not a gift card you would stick up to your ear and listen to. This is for an Audible subscription through Amazon. And finally, VaultSpeed will be providing the Belgian beers shipped to anywhere in the world. I would not recommend opening them right away. Our first winner, Ben Williams, with Resultant giving him a $50 Amazon gift card. Up next, Data Rebels will be providing a $50 Amazon gift card to Sabu Varghese. I believe that's the correct pronunciation. Eon Collective will provide a $50 Audible gift card to Jen Freeman. Congratulations, Jen. I do believe she was attending earlier and may still be on. Warescape providing a $50 gift card to Sean Tressler. Congratulations, Sean. VaultSpeed will be sending Belgian beers up to Lane Isles. You're welcome, Jennifer. Thank you. And Seven Rivers will provide a $50 Amazon gift card to Simon Fasanya. Now, I'm not sure I'm pronouncing that name correctly. Simon, correct me if I'm wrong. I don't believe Simon was on today. Data Vault Builder, providing a $50 Amazon gift card to Maury Hamill. That's Maury Hamill. And I believe Maury was on today as well. So congratulations, Maury. Joseph Lee will receive a $50 Amazon gift card from Infovia. And that wraps up our winners for today. Congratulations to all our winners. We do want to thank everybody who attended today's presentation. Raina and Kent, phenomenal work today. Thank you, Dan, as well, for your words of wisdom. We are looking forward to the next presentation coming soon. Back to you, Cindy.
All right. Thank you, Noel. All right, Janet.
That's me. Our next, really interesting, I'm looking forward to this one. Our next meetup event is going to be on the 19th of June, and it's going to be talking about the automate quality assurance for your data vault. And that's Matt Aggie's going to do a presentation from Validator. So that's an interesting one I'm looking forward to.
And we're also going to have a presentation, I believe, from Gail Bunn. Is that correct? She's going to talk about her process for
cool.
Automated testing as well. So,
Yeah.
Oh, cool.
Yes, Gail will be on.
okay, great. Thank you to all of our sponsors. I am going to click us over here for our social media links if anybody's interested. And that is really about all we have. So we look forward to seeing everyone in June. And thank you very much for all of our speakers, our presentations. Dan, thank you for taking your time. Kent, Raina, thank you for hanging in there with us. And then for all of our audience, we do apologize for going over about 20 minutes, but we do appreciate your patience. And, we love feedback. So give us some feedback on how you enjoyed the session and what you'd like to hear in the future. We'd love to be able to present more information, different topics, different vendors, etc. So we'd love to hear from our users.